Okay, so this is some announcement quickly. Lab number 4 was released on Sunday or Saturday evening. But now, what I want to warn you about, there is certain things called ETF, Eiffel Testing Framework. It's quite a big thing for you to get used to. So I would suggest you go to the tutorial video for the ETF, and there was a link on the course forum and also on the instruction. I would say start with this first. That will save you a lot of time, okay, for lab 4. It's quite a big lab, but if you do it properly, it's going to save you lots of time for the projects. Okay? Again, go to tutorial videos and everything will be clarified for you. Okay, what we left off from last time was about the once routine in Eiffel. So let me just describe very quickly about once routine, and then let's see why it can be useful for our singleton pattern. And before we talk about singleton pattern in Eiffel, I would like to show you two possibilities in Java and try to criticize on that and see what can be the final solution. Okay? Again, so this is the new keyword we want to get used to. So it's called once. So rather than having do, we simply got once over here. Once simply means the following. For the very first time you try to call the feature, it is going to execute the body of the feature line by line and then return whatever the return value is. And then it's going to cache the value for the return value for all the subsequent calls. And this is how we got shared data for the singleton pattern. For example, you can see that over here, let's say we got test once query over here. So this is, when I say ARR1, so that's some array, and simply a.new once array over here. So this is the very first time that we try to call this particular feature that is once. Okay? What you would do is, you can see it's going to return an array of string. So the array is going to return simply to be empty to begin with, and whatever argument value you pass over here, which would be Alan, simply put Alan inside the array. So what you would get is something like this. You simply say ARR1 is simply just pointing to this particular array with just Alan inside. Okay, that's for the very first call to the once routine. Now, all the subsequent calls to the same once routine, we are not going to execute the body of the feature anymore. All we're going to do is simply return an alias of the original return value. That's all we will do. So now, if you look at line number, this particular line over here, we got ARR2, which is simply just another array reference. And we say that it's going to call this particular new once array. You can see this is not the first call anymore. So this is not the first time. As long as it's not the first time, what we will do is we simply return. So you can think about somehow this result for the very first time is cached somewhere by the system. Okay? And now we simply say ARR2, simply just going to point to this particular array without executing the body of the feature anymore. And last time, some of you actually pointed out, this mark over here is simply just ignored. It's not useful over here. So typically for the once routine, you don't really take any input arguments, typically. Okay? So that's a very quick recap. Okay? So now let's consider more properly. So I added one new slide for you. So now let's consider two possibilities for implementing the singleton pattern, especially you want to have a shared data. How would you do it in Java? Let's think about two possibilities, and then we'll try to criticize on them and see how we can have a more perfect solution in Eiffel. Okay? Let's have a quick look. So now, by the way, this is Java. Okay? So now let's say what we have. Sorry. Okay. So now for the Java version number 1, so let's say we have a bank data class over here, and then we simply got some constructor. Let's say we're in the same package, so we don't have to put public. And then we got interest rate, that's the only data, and also we have a mutated method set interest rate. Okay, very easy bank data class. We have another class over here. So the good thing about the first design in Java is it's a separation of concern. We have data class, and also we have access to the data. So we got two separate classes. Okay, so we want to make sure every class do one thing and do it well. Okay, and now we simply got some static attributes over here. You can see the first one is whether the initial call to the constructor has been made or not. Okay, and also we also got the data over here. You can see simply static, which means shared among all the instances for the bank data access. And then we simply got this one here. So this is just another method here. So typically people call this factory method. I'll just put it here, factory method, which means it's a method that's going to return to you some instance. So now let's have a quick look to see how exactly this can be executed at the runtime. Okay, let's talk about a little bit Java here. Let's say for the client's code, I simply say, let's say bank data access. And then, okay, I say bank data access is simply new bank data access, right? I'm just saving some writing over here. So now, if I say bank data over here, let's say data 1 is simply assigned to BDA dot get data. Okay, so now this is basically simulating what's happening for the once routine. So we're calling this for the very first time. Okay, let's see what's going on here. So when we call this for the very first time, get data, what it will do is init once over here, initially is simply just false, right? Remember for Boolean variable, it's always false to begin with. And now you can see initially this is simply false, not false will give you true. That means for the very first time, we're going to execute these two lines of code. And then it's simply just going to create a new data and then set the init once to be true. Agree? Okay? So what it will do is data 1 is simply just going to point to a bank data objects. Bank data objects. That's for the very first one. Are we okay so far? Okay? The tricky thing really, the trick is really we set this initial once to be true. Okay, it's now true. And now let's say we try to call this a second time. If we say bank data, and then we simply say D2, which is BDA.getData. So now what's going to happen this time? Well, remember the init once has been set to true already for the very first call. So that means when we try to call this get data over here, so at the moment init once is simply just true. Not true will give you false. That means we're going to bypass this particular branching body here and simply return the data, right? So that means D2 is simply just going to point to this particular BD. Oh, one thing I forgot to point to. So you should really remember that this is why we simply got data over here. It's a static attributes. So data is always pointing to this particularly initially created objects. Okay, one more thing to say. How do we have singleton over here? If I simply say, let's say D1 dot, let's say set the interest rate to be, for example, 1.23. Okay, it's simply going to set it to be 1.23. Now D2, the interest rate will also become 1.23, right? It's aliasing. So everything's being shared by D1 and D2. Of course, you can create more like data 1, data 2, data 3, data 4, etc. Are we okay so far? Yeah. No, there's no inheritance here. We are doing something very simple. We're simply using a static. Remember what static really means in Java. Static simply means it's going to be global to all the instances for the particular class. So we are maintaining only one single Boolean attribute, which tells us whether the very first call has been made to this particular getData method. And also the data over here is also static. That tells us which is the shared data you're maintaining, right? So that's why these two are static. Okay. And this one here, static method simply just return to you the data that's being shared. Guys, are we okay? It's only Java, right? Apparently, in Eiffel, you don't have to do such housekeeping. You don't have to worry about the Boolean attributes. You don't have to worry about the data. Everything will be done for you as long as you declare things to be once properly. Okay? Any question about this? Okay, so now as usual, we don't really just learn about things blankly. What we want to know is the following question that's more important. Any problem can you see for this particular design in Java? Okay, anyone want to try? That's all the code you have to use. Oh, let me just say one more thing. Of course, so bank data and also bank data access are the supplier, and this is the client. And the client can simply say data is assigned to bank data access.getData. That's all we have to say, right? The clients. What's the potential flaw of this design over here? Let me give you a little bit hints. The very purpose about Singleton pattern is we want to have only a single instance for the data, right? However, according to the current setup, is it possible for me to do something over here in the client such that I have more than one instance created for the bank data? Yeah, exactly. Yeah, that's exactly right. So this, at the moment, there's nothing stopping me from doing the following. I can say data, let's say, I need to declare another one. I can say bank data, I can say D2. It's simply, rather than using this factory method here, I can say new bank data. Nothing stopping me from doing this, right? And this data here and this D2, if I say data equals D2, it's going to be false. Okay? So now we are breaking the singleton. Okay, are we okay with this? So the first one, the first version of Java almost work, except that if your client wasn't cautious enough, they might easily create another new instance, in which case you don't have singleton anymore. The very spirit about singleton is there's only one single data to be shared. Okay? Are we okay with this first version? Okay? How can we improve this first version though? Well, in 2030, remember we talked about something called utility class. Utility class has a very special feature, which means you cannot instantiate the utility class directly, which means you can declare the constructor to be private. Okay, let me show you. Because it seems like we simply just want to make sure this line here cannot occur. And one very naive solution would be, why don't we simply make the constructor over here private? Which means any class outside this particular bank data class just cannot instantiate that, just cannot call. Okay, that's kind of intuition. So now let's move on to the second version of Java, okay? Second version. Now the second version over here, you can see apparently for the supplier side, I collapsed the bank data and bank data and bank data access into a single class, right? Let's go over that very quickly. I still have the same logic as before. I still have these Boolean flag and also Boolean bank data. Also, I still got this factory method the same as before. The only difference is over here. I have private. Okay, so that means that if any clients who want to use this, let's say I have client over here. Okay, let's say the client. And then now if I try to say bank data, D1 is simply new bank data. Would I be allowed to do so in this case? Well, apparently not, right? Do you see why? Because the constructor over here is private. That means any class outside this particular bank data class simply cannot call this constructor. So this is simply not going to compile because it's private. So this solved the previous problem. Are we okay with this? Okay, however, this is not a good design. What's the problem here? Well, you can still set it. Well, you can still set the interest rate. That's not a problem. So you can still do it. So whenever you say you want to set the interest rate, so maybe you know what? It's a good point. Maybe what I should have said. Maybe I should say this is a static method over here. Whenever you say set interest rate, it will just set the interest rate to the single instance. So that will still work. Not a problem. Okay, that's not a problem. I tell you what, at the runtime, this can be a working implementation. But from the design point of view, this is not so good. Okay? Basically, this corresponds to what we discussed before. It's called separation of concern. Separation of concern. So what are the two concerns we have? We have data, and also we have data access. You should not try to mix both concepts in a single class. That's not good. So apparently over here, you can see this part over here, this part. Okay, let me just try to, so this part over here is about the data access. Whereas, oh, sorry, this part is about data. Okay, this part is about interest rate and etc. And this part over here is about data access. And somehow in this second version of design, we try to merge the two concepts together into a single class. That is not good. It will work, but it's not a good design. So every time when you have a good design, that simply means every class should have a coherent purpose. So data and data access, they are two orthogonal issues over here. So you want to separate them into two classes. Okay? Guys, are we okay? So we kind of learned something from the two versions of Java code. Number one, we want to make sure no one can actually explicitly create a new instance of the data. Number two, we want to make sure data and data access are separated into two classes. So these are the two things we want to achieve. However, none of the Java version could do that. Okay? Now, how do we do that in Eiffel? That's why I said the design over there in Eiffel is a little better one. Okay? Design. Let's now, so now we're pretty much done. So now we just have to see exactly how the singleton pattern looks like in Eiffel. We're gonna have two of the criteria satisfied. Okay? So now let's have a look. Okay, let me see if there are any more slides to show. Okay, you can definitely have a look at the two versions of Java. Okay? So now let's talk about singleton pattern. Okay, again, let me just go over the code with you. Okay, so now let's see. So there are some minor details you want to really pay attention to. Okay? First of all, we have data versus data access. So the separation of concern. Okay? And then I will talk about this guy here a little bit later. Notice that we say create and also we say make. However, we put some export status right before the constructor name. There's a reason for that. I'll get there in just a moment. And also for the make feature over here, we also have data access over here. That simply means only the data access class can make a call to the make. Okay? So now I want to highlight this part particularly, this part over here. This is something I'll get into as a last point. Okay? And then, so here, let's say for data for make here, we simply initialize the value to be 10. We just talk about some very simple data to be shared. Okay? And then for now, for data, we also got v as an integer, and also change the value for the data, okay, to be some new value. Okay? Very simple class, just to illustrate. You can imagine that the data here can be changed to bank data, or whatever data you like. And for the ETF platform framework you're supposed to learn in Lab 4, we do have a singleton pattern over there as you walk through the tutorial video. Okay? So now, one more thing to say about the supplier. We have a class called data access, and there is something called expanded over here. Remember we talked about expanded before? Okay. So now we'll see exactly why this would be beneficial to say that's expanded in just a moment. Okay. Then we'll see that here we have data attributes, which is of type data, and we make that as a once routine. Okay. The once over here is also very important. That means the very first time we call the data, we are really going to execute this line of code, which is to create a new data instance. For all the subsequent call to this particular make feature, we're just going to return the cache value, like an alias to the data. Okay, I'll trace the code together with you. Any questions about the supplier side? Of course, except for this guy here, which I'll talk about in just a moment. Okay. So now, let's have a look at the client side, and let's trace the code together. For the client side, we have a test over here. So now we have access, And then we have data 1 and data 2, right? Different names. Now, a question for you. Do you think this line will actually compile, given that I didn't really initialize the access? That's exactly right. So the reason that we actually got expanded over here simply because we don't have to say creates access.make, for example. We don't have to say that every time. It's just for that convenience. Okay, we don't have to say that. Okay, no need. Because it's expanded. So every time if you want to just get a shared data, you can simply say access, which is of type data access, which is expanded. You can simply say .data and .data here. Okay, so far so good? Okay, let's now trace the code very quickly. Okay, so now let me clear that a little bit and then we'll try to trace it together. Okay, so now for the very first line, D1, okay? So you can see access.data, so this is the very first call. Okay, so what you will do is it's going to execute this data, which is once, and then it's going to execute this line of code, which is going to create a data. So what you will do is, so now D1 is now going to point to a new data objects over here, and you can see from the constructor, initial value for the data should be 10, right? Just 10. Okay, that's it. You can think about internally, the system simply maintain the reference to this particular objects. So for any subsequent call to access the data, they will simply return the same object's reference. Okay, no new objects will be created, not anymore. Okay, so now that is why when we try to do this line here, when we say access the data into D2, so this is not the first call anymore. So that means we're not going to execute this line anymore. We'll simply just return this particular reference that's being cached. And then simply D2 is now pointing to the same data. That's how we create singleton. Okay. So now D1 and D2, they are pointing to the same object, so we do have aliasing. So now that's why when you say D1 equals D2, reference comparison, it will simply just be true, right? And also D1.v, so D1 following the pointer, you got D1.v, which is 10. Also D2.v, so follow the reference over here, also the same value. So they should be the same, both 10. Okay? Now, one more thing to double check. If I say D1 over here, dot, change the value into 15, for example, right? So D1 is now pointing to this particular object over here. I say change the value to 15. I'm modifying this to 15. Would that affect D2.v as well? Of course, yes, right? So that's why you see both will be 15, and they're still pointing to the same reference. Guys, are we okay? Okay, we're achieving exactly the same thing as in Java. Now you might be wondering, well, how could we avoid the previous problem that I talked about over here? Because you can see previously in the account class, in the version 1 for the Java, I could still try to create a new instance of the bank data in another class rather than using the factory method. Okay? This is why we had this particular export status over here. Okay, let me show you. Okay? That's really the subtlety you have to pay attention to. Okay, I'll show it to you. So now, when you say class bank data, okay, and then you say creates, okay, it's called data access. Data access, and then we say make. Okay, and the rest is simply following the slides. Okay, so this particular export status over here is really critical. So what does that mean? That means only the export clients over here, so only this class, only these clients may create an instance of bank data. using this constructor. Okay, in this case, just make. We're declaring make to be a constructor, and this particular export status over here is saying that only the data access may call this particular make constructor, which is exactly what we did. You can see that over here in the data access class over here, we try to call creates result.make. Okay, you can see that over here, and then you can see the make over here, right? Try to see that. Okay, they correspond to each other. So now let me try the following to show you. You can try that on Eiffel Studio as well. Let's say I just have another class, pretty much like how I did for the Java code over here. Let's just call it account. What if I try to create another bank data instance over here? Let's see. Okay, what I would do is, let's say class account. Apparently you can see account is not the same as data access, and then end. Let's say I simply got some feature f and do an end. Okay, let me just put a local maybe. Okay, I got a local variable, and the local variable, let's say simply bank data. Okay, so now let's try to create an instance of bank data. If I say create bd.make, now do we expect it to compile over here? Well, very easy for you to judge. Okay, this is how you judge. You can see that we are trying to call this make as a creation procedure. However, this particular creation procedure is referring to this particular declaration over here. However, it gave you some restriction, telling you that only this class can call that particular creation procedure. And this class is not a current class, so it's not going to compile. That's how we restrict the access for creation procedure. So we can avoid the problem for the Java code, version number 1. Okay, are we okay with this? So now the question is, how do you get a new instance in the account class? What should we do? If I want to get a new instance for the bank data in the account class, what should I do? I should really try to use the bank data access, right? Okay. What I should do instead will be something like this. Okay. What I should do is I should say data access over here. Okay, instead, I'm going to say BD is assigned to data access dot data. So this will be okay, right? That's how we enforce the singleton pattern. Okay, so there's a shared data, number 1, and also only the data access class can explicitly create a bank data objects. Questions on this? Everybody is okay? Okay, good. Okay. Okay, that's singleton pattern. Let's see what else. Okay, that's something I just mentioned. Okay, if you simply just try to say d1.make in any other class, it simply wouldn't compile because of the data access restriction over here. Right? Okay, another one, which is going back to the original problem of bank data. Okay, I wouldn't really bother you with the details. It's pretty much the same as what we just talked about. I'll just highlight to you the critical details over here. Okay, that's just another example here. So what we should see is, again, you can see there is this particular restriction on the constructor over here. Okay, number 1. Okay, so you can see that detail there. And also, you can see we declare the data access class to be expanded. Okay, and also the factory method here will simply declare that to be a once routine. Okay, so these are the details you want to make sure you satisfy. And then now in the client class, the way we get a new data instance to be shared is by, first of all, declaring data access local variable here. And because it is expanded, so we simply have to say data access the data. Okay, exactly the same instantiation for the pattern. Okay, So every time you want to implement a singleton pattern, that's all the details you want to pay attention to. Okay. One more thing to say. You might be wondering whether the expanded part is really necessary. Remember what I said before, the only reason for expanded over here is whenever you want to really say data access.data, you don't have to explicitly create the objects. That's only for that purpose. So for you, if you really find this part confusing, you can take it out. That's okay. You just have to make sure you explicitly create data access objects before you call data. Okay? That's kind of a minor issue here. But the main thing about singleton pattern is, again, is number one, you have some restriction on calling the creation procedure. Number two, you have the once routine. So these are the two most important details. Okay? Guys, are we okay? Singleton pattern. All right. Okay. So for example, if I simply just give to you a question like this, I simply give to you, let's say, pretty much the same code, but I simply take out this particular export status. Okay? And the question is this an appropriate implementation for the singleton pattern? The answer should be no, right? But why not? Do you know how to explain to the questions? Do you know what my question is? I simply give you pretty much the same code, except that I took out this particular important detail over here. So now, how do we know this cannot be an appropriate implementation for, or appropriate design for the singleton pattern anymore? Why? So you're saying that it's now possible for us to create more than one instances for the bank data. How? Yeah, actually the reason is now if you took out this particular export status here, that means you can create more than one instances for the bank data, even though you got once. Yeah, you can call the make anywhere. Yeah, exactly. Okay, so make sure you are comfortable with this answer here. So now over here, you can simply say, rather than saying data to access, well, pretty much like a version 1 for the Java, right? I can still say creates data dot make. Okay, this is actually allowed if I took out the restriction. Yes. Yeah.
So you said that will allow us to call methods
without initializing it. Because for expanded type, as we said before, it's going to be initialized automatically. Yeah.
Does it initialize any particular?
Oh, so the way they initialize is simply just going to, well, if the expanded class has any attributes, it's simply going to give the default values. If there's no, we simply just initialize the object itself. Yeah. But as I said before, the expanded here is not so relevant to this particular singleton pattern, just for convenience. Yeah. Okay, are we okay with this? Okay. All right. Yeah, and then over here, when you look at the slides, I also got some test case for you. Pretty much the same setup. I'll just again highlight the difference for you. Okay. For the bank data case. Okay, so whenever you want to understand the behavior for the singleton pattern, you want to know that the very first call to the account. In this case, the account is simply just over here, right? The account. And then when we call the make over here, we're simply going to call data access.data. So this is the very first time we try to call data, right? And data is the once routine we have. Okay, so now I can say that this is the very first time calling the bank data access. Bank data access dot data. So that's the very first time. In which case we're going to create an instance first. So that means ACC1 is now going to point to some account. Okay, and the account somehow has some bank data over here. It's going to point to just some data objects over here, bank data. Okay, and now what about the second line over here? So this is the second time we're trying to call that, second time. what it will do is simply, again, we're going to create a new ACC2 account objects over here. But now, when we try to call this particular line the second time, right, the second object to be instantiated. So now when we say .data, so we're going to call the data here. Now this is not the first time anymore. So that means it will simply just, the data will just point to the same bank data objects. So there's an aliasing for the bank data. Okay? That's after this line here. Okay? Like that. So that is why when you try to do a reference comparison between ACC1 data and ACC2 data, it will simply be true. Okay? More importantly, since now the data is being shared, there's only a single instance for the bank data over here. So when you try to say ACC1.data.set interest rate to be 3.11, so definitely say 3.11 here, and that's going to affect both ACC1 and ACC2, right? Similarly, if you try to say ACC2.data.set interest rate to be 2.98, in that case, it will still do the change over here, 2.98. And that's also going to affect both ACC1 and ACC2, right? The same idea, okay? The same test setup, just in a different example. Guys, are we okay for Singleton? Yes?
This might have already been answered, but what's preventing me from making my own, let's say, bank data access class?
Oh, that's exactly, yeah. So what really prevents you from making your own bank data instance, right? Okay, yes. The answer is over here, yeah, this guy here. Okay, this is really the crucial part. Because for this part here, when I declare the make constructor here, I'm saying that this is only exported to this particular client, which means only the bank data access can create a bank data objects, not any other class. Okay? If you try that outside this particular bank data class, outside this bank data access class, it's going to give you compilation error.
And let's say I made let's say I just named created a new class with bank data access again. I told you said, oh, you're creating another.
Yeah, the same idea. So basically what you're saying is, if you simply create another class, let's say class bank data access number 2, right? And then over here, maybe you try to duplicate exactly what we're trying to do here. Data, and then bank data, and then I say once. No, this is a good question. Let's say I say once, and then I will say creates, exactly this line here. Creates result.make. Now, is this going to compile though? Who thinks that should compile? Okay, nobody, okay. So now, this will not compile. The reason is simple. You can see over here, when we try to call this particular creation procedure over here in the context of bank data access 2, we want to see what's the restriction for the original class. And the restriction is, it should only be called by this particular class only. Okay, it's not that class, so it's not going to compile.
What about classes that inherit from bank data access?
What about other class that inherits from that? It's a good question. I don't think that will work. Because, okay, I can double check for you. Okay, basically you're asking the following. So we got bank data, and then basically you're asking the following question. Bank data access over here, and then make. Okay, that's one class we have. And you're asking, let's say we got bank data access. Okay, that's one class. And then let's say we got another class over here. Let's say bank data access number 2. So now you're asking whether we can, in this class, can we say creates data dot make? I believe you cannot, Because usually when we talk about export status over here, it's more about just a clients. So you must match this name verbatim. So even though this is subclass, you wouldn't really conform to this particular restriction. So I don't think you can. But I'll double check. Okay, yes. Yeah. Yeah. Oh, you mean over here? Yes, indeed. The other one? You mean, which one are you talking about? Huh? Oh, you mean over here? Oh, I see what you mean. I see what you mean. Yes, you can. No, that will be okay. You're basically asking the following. Okay, let's try. So now you're basically saying class, account, okay, and then end. Let's say for the account, we simply say local. Oops. Let's say data access 1, data access 2. And then I simply say bank data access. Okay, and then let's say we have data 1, data 2. That's an interesting question. Okay. Bank data. Okay, and then we say data 1 is assigned to, let me just be consistent with the name. Data 1 is assigned to data access 2 dot data, and data 2 is assigned to data access 1 dot data. Okay, well, 1 and 2 doesn't really matter. I'm just trying to flip them just for the sake of being more interesting. Okay, now let's say after this line, if we simply say data 1 equals data 2, should that be true or false? Well, it can be either true or false, right? Yeah. Okay? It should be true for the following reason. Again, this might be this can strengthen your understanding for once. Okay? Remember what the once is. Once applies to all the instances for a particular class. So now for data access 1 and data access 2, they all refer to the same class over here. Okay? So now when we try to do this particular assignment over here, when we say data access 2, it's going to call the data feature. That means it's going to call this particular data feature for the very first time. And because it is once, that will be the first time. Okay? So after this, it's simply just going to create a data over here, and then data 1 is simply going to refer to it. So now for the second time, even though we are using a different instance for the bank data access to call that, but they're the same class. Right? So now it's really crucial for you to see this. So this is the second time that the bank data access the data once routine is called. And because that's not the first time anymore, so data 2 will simply just refer to the same data objects. So it's quite a good question. Yeah. But typically, you may have as many data as you like, but you may have only one data access object. But if you have multiple, that's fine. It will still work. Yes. The reason really is the once over here is a little bit like a static in Java, which means it applies to all the instances for the class. Okay? Wow, how much? Let me see. How much time do I have? I got 6%, which is not good. Okay, so now, any more question about Singleton? Are we okay? Okay, good. So now, I would suggest the following. Because my battery is dying, can you just give me 1 minute? I'm going to run back to my office, take the power, and then I'll come back. Okay? Just take a 1 minute break. right. I'm so grateful we are not in the tail building. Okay, so okay, guys, any question about the singleton pattern? We okay, right? Good. One more thing to say. Architecture for the singleton pattern. So now, again, this is a bond diagram, and then we should really see the details about the singleton pattern here. So this time we did it a little bit differently than the iterated pattern. In the case of the iterated pattern, we learned about the architecture first, and then we learned about coding. But now for the singleton pattern, we do it the reverse way. Hopefully you're comfortable with both. So now for the singleton design pattern over here, let's see exactly how things will be designed over here. So you can see, first of all, separation of concern. We got data access here, and also we got data. Okay. In the case of data, you may have different attributes, for example, value or some command, like a mutator. And then you have some data, access export status over here. So this is really important. We are saying that we are restricting the access for the constructor to be only to data access class. And then we have also the data feature over here, which is once, right? So everything we have set already. And then you can see there's a client-supplier relationship over here. Data access is simply just a client of data. So why is that? So every time when you see there's a return type over here. So in this particular class, we are using the data as a return type. That's why data is simply a supplier for this class. Okay, so that's how we got client supplier. One thing that's really important about the singleton pattern over here, class invariance. Can you have a look at this particular invariant over here? What does that mean? Data is equals data. So what does that say to you? When I say data equals data. First of all, syntactically, what does that mean? Data is simply one call to the data routine. The right-hand side, another call, right? It's quite obvious, but I'll just write it down anyway. To the data routine. And we also got another equal sign in between. What does that mean? That means for any subsequent two calls to the data routine, the return value should be the same. Reference equality. That means we have shared objects. Are we okay with this? The invariance. Okay, that's why this invariant over here is really telling you you got a singleton pattern. Every time you try to call data, it's always going to return you the same instance of the shared data, always. Okay, finally, one more detail to mention. Remember for data access over here, that was expanded, right? Just remember, okay, in our particular implementation. Now, if I have, let's say, account as a client, for example, account. If the account class is using the data access class as a supplier, so we have a client supplier over here, but notice that there is a particular way for us to drawing the arrow over here. So whenever you got client supplier, okay? So now if you simply got an arrow like this, versus you got another arrow like this. Okay, that's a bit. Another arrow like this. Okay, so what's the difference between these two? Okay, the first one simply means the supplier is a reference type. On the other hand, if you got some vertical bar over here, that means the supplier is expanded type. Okay, just a way to distinguish. Okay, yeah. I think for lab number 4, you're actually going to draw some bond diagram for the submission. I'll try to give you a little bit mini lecture, maybe Wednesday or next Monday, to give you a little bit guidance on drawing bond diagram. Okay, but we try to learn details by seeing the case study. Okay. Any questions? That's the end of the Singleton pattern before we talk about inheritance. Okay. Everybody's comfortable? Singleton pattern? Okay. Which one do you like more? Iterator versus Singleton? Singleton? Oh, really? Okay. You don't know? Yeah. You can say neither, right? That's fine. My favorite pattern is called visitor, which we'll get into after the reading week. That's my favorite pattern. Yeah, we'll get there. Okay, so now let's talk about inheritance. Okay, there are many subtopics about inheritance. We'll start with about code reuse, basically how you use a super or precursor keyword. In Java, you talk about inheritance using a super keyword. I'll just give you a very quick example about how you can use the same construct in Eiffel. That's more about code reuse. And then we want to move on to talking about subtypes, especially when you have an assignment to say, I'll give you a quick illustration here. Basically, the most important topic about inheritance is, okay, let me just give you the general guidance over here. Oh, thank you. Thank you. In general, if I say object 1 is assigned to object 2, if I say objects dot, maybe calling a feature with another object 2, okay? Or if I say object 1 is assigned to f, and then maybe object 1. So these are the very general forms of writing object-oriented code. Eventually, we want to know when the inheritance is present. How do we judge if each of the lines over here is going to compile? Okay, that's what we'll go into, maybe from Wednesday. Okay, this may overlap with what you learned from 10-20-30 if you took the 10-20-30 with me. But if you have not, that's okay. Hopefully we can get some new insight for you. Okay, so these are the things we're going to focus on, maybe mainly on Wednesday and next week as well. But for today, I'm going to talk about something light, about code reuse. Especially at the end, I want to give you some very interesting case study, how you can test the postcondition using inheritance. Okay, we'll get there. So now let's talk about inheritance quickly. Can you just take, okay, for the aspect of inheritance, there will be 2 aspects for the inheritance. Number 1 is about code reuse, which we'll talk about today, and also substitutability, like what kind of assignment can be done, which be compilable. Okay, that's kind of the thing we'll focus on. And polymorphism, dynamic binding, which will be also very critical for you to understand design patterns after the reading week. Okay, and then subcontracting. Okay, this is also something you haven't learned before. So far, you have seen in your lab 1, 2, and 3, in the subclasses, you see something like require else, ensure then. So these are something called subcontracting, which means when me as a superclass, when I got pre and post condition and invariants, what does it really mean? When I have my children, what do I inherit to them? And how do I inherit the contracts to them? That's kind of the subcontracting. So that's something we'll get into most likely after the reading week. Okay, now let's talk about the use of super keyword or precursor keyword in Eiffel. They're completely equivalent. Okay, so now can I just ask you to read very quickly about this example here. Okay, just take 1 or 2 minutes quickly, so that will save time. We're going to use this example throughout the next 1 or 2 weeks. Especially pay attention to how many classes should we need, and also what attributes and what methods or what features should we support, right? Things like that. For those of you who took 2030 with me, this might seem familiar. But many of you didn't take it with me, so I'm going to assume it's going to be new to everybody. Okay, maybe another 30 seconds. Okay, just make sure at least you know what's going on over here. Yeah, I think it's a reasonable example. You got classes, you got attributes, and also you got different methods, right? Okay, are we good? At least understand what the problem is. Okay, now the exercise we're going to do together is how do we design classes that will actually satisfy all the requirements over here, right? Let's say without the inheritance. Without the inheritance, how can we do this, right? Yes?
You have one student class with an attribute to know if they're a resident student or not.
You mean like a Boolean attributes? Sure. I like that design, except let's think about the following. Okay, let's say we judge to see if that's a good design or not. Yep, no, I know. So what you're suggesting is something like this. You're saying that we have a student class and then we might have is, let's say, residence. Let's say Boolean, right? When it is true, that means the current student instance is a resident student. When it is false, that means it's a other student, non-resident students. Okay, this might work pretty well when you have only two kinds of students. What if you have A kinds of students? How would you follow this particular mechanism? You might need something like that, right? You might have, for example, you say Boolean 1, Boolean 2, and Boolean 3, for example, right? And Boolean. And now, given the true and false, and true and false, different combinations, how do we know which kind of student we are? You might say, oh, if you happen to B1 and not B2 and B3, that means this is one kind of students, right? If you got not B1 and B2 and not B3, it's just another kind of students. You see what I mean? Okay? So this may not be a very good design when you extend the problem to be something bigger. Okay? And more talking about maintainability for your design. Okay? Guys, do we see the disadvantage for this design here, right? Good. Yes, question? Answer. Two different classes. What do you mean two different classes? Yeah, exactly. That's what I have in the slides. Because I restricted to say you cannot use inheritance, let's see, you got one resident student and the other one is non-resident students, right? So what do we anticipate to see if there's no inheritance? We should see lots of code duplicates. Let's see how. Yes?
No, I want the same one.
Sure?
I'm saying so because we have the Boolean. From non-resident students, resident students have two different methods that are different.
That's also true, yes.
You have to put both of them in there.
Exactly. That's exactly right. So just adding more to Adam's point. So maybe you have some, let's say set premium rates, which is only applicable to non-resident students, right? And also set discount rate, that's only applicable to another kinds of students. In that case, you're fitting two things that are not really relevant to each other into a single class. Cohesion, right? Not coherent. Okay, that's another issue here. But it's a good try. Good. All right, that's good. So now let's see the code very quickly, okay? Because I do want to get into the case study that's more interesting. Let's just go over the code very quickly, okay? The code itself is very easy. I just want to show you the precursor feature. Let's say we have a course as well. Let's say we have a course class. We got title for the course. We got the fee for the course. And also that's how we create a new course instance with the title and the fee. That's easy. So now let's see this. Let's say we got a class called resident students, okay, as you suggested. We have a make feature here. And then let's say we got name, we got courses. So the list of registered courses for the student is simply a linked list. And then we got premium rates, which is only applicable to resident students. And then we got the make feature for the resident students, which means we initialize the name, and also we create the courses to be empty to begin with. And then we can set a premium rate for the resident students, okay, simply set a premium rate to be something. And then we can register for the particular student. Let's say for the moment the policy is we don't have any upper bound for the number of courses. We might change that policy later, okay? And then we can also calculate the tuition. Let's say this is how we calculate. You simply add up all the course fee for the students. And then we apply the premium rates. Okay, well that's why you see something called base over here. And then we simply go across all the courses, add up the fee, and then eventually we say result is simply base multiply premium rates. Okay, very easy. That's the first class. Now, if I want to create another class called non-resident students, do I expect to see many duplicates in the code? What exactly will be duplicated? Well, basically whatever that's not highlighted in yellow will be duplicated, right? As you can see. Let's see. Well, let's just imagine what's going to happen. If I want to create another class called non-resident students, I just have to change the class name over here to be non-resident students, right? And now rather than having premium rates, I'm going to have discount rate. And then rather than having set premium rates, I'm going to have set discount rate. And then for the tuition, you can see, even though it's not completely duplicated, but most of the parts duplicated, the way we calculate the base rate is just the same for the two kinds of students. It's only the last step that is different, right? So now if I go to the next slide, let's see how we create the other class, non-resident students. So we got non-resident student here, and then we got a creation procedure here. And then you can see we still have to duplicate the declaration for name and courses, right? The same. And then we got discount rate, which is different, okay? And also we got a make feature, which is completely the same as before. And also we got set discount rate, okay? That's different. And also we got register, which is the same as before. Also we got the tuition. You can see the way we calculate the base amount is just the same, except that at the final step, rather than applying the premium rates, we're going to apply the discount rate. Okay? You can see there's a lots of duplicates for the two versions, for the two students. Okay? Now, let me ask you the following design question. Okay? What's really the flaw for this particular design? Any of the design principles that we talk about so far is violated by having two students that look so similar. Design principle. Well, copy and paste. Yeah, I think you're on the right direction. But what's the design principle name? Starting with S? Huh? Simplicity. Well, not exactly, but single choice principle. Okay? Again, let me remind you again. Single choice principle simply means whenever there's a change on your design, there should be only a single place or the minimum number of places to modify your design. Now, how do these two classes violate the single choice principle? Yeah.
So let's say you want to change, let's say, something like tuition, how it's calculated.
Yep.
You got to do the same for the other.
Yep. So, for example, if you want to change the way you calculate tuition, or the way you want to calculate, want to register for the students, you want to go to both student classes and modify them. So the multiple places you have to modify. Okay. Yeah. Okay, let me show you exactly that on the iPad quickly. Okay, over here. So now these are the two classes we just talked about, right? Let me just talk about tuition here. Okay. So now let's say this. At the moment, we got tuition over here in non-resident students, and also we got tuition in resident students. We got these two classes, right? They are basically almost completely duplicated. Okay, almost. Okay. So now, let's say I want to do the following change. Let's say I just want to apply more rates for the tuition. Let's say inflation rate, for example. If I want to say the base multiplied by discount rate and also multiplied by inflation rate. Apparently, I cannot just change this one only, right? I got to change both places. That means not only here, but also I got to change to here as well. Okay, premium rates for the resident students and also inflation rate. So this is violating the single choice principle. Now, let me just finish one point. Imagine that if we got 10 kinds of students, how many places do you have to change? 10 places. Okay? Again, always think about design in the big context. Whatever you're working on right now may be a very small problem to begin with, always think about how you might extend the problem and judge your current design, whether that's suitable or not. Yes? Deferred class, we can talk about deferred class a little bit later. It's more like you want to leave some feature unimplemented. But in this case, maybe not. Because in this case, we can see that for every feature here, they got something to be shared between the two subclasses. So that means you want to put something in the superclass. Okay, so that's about single choice principle. That's the most important thing to really capture from this particular lesson here. Okay, so now I want to say one more thing about these two versions here. Of course, you can read through this particular test case. We simply create a student object and try to do some registration. That's a very easy test case, okay? I want to go for this particular one. Okay, duplicates and also single choice principle. This is the official definition for single choice principle. Okay, just make sure you know what the principle is. When you do your lab number 4, try to follow that as much as possible. You want to make sure you have information hiding and you have single choice principle, right? These are the two. Okay, so now, that's a change we talked about. So one is about register, and the other one is about how to calculate tuition, which we just illustrated. There's another drawback. Okay, at the moment, we got two classes, resident students and non-resident students. They're completely independent, right? So now I have a question for you. Let's say I want to have another class. It's called Student Management System, which means I want to collect all kinds of students. So now, according to the current setup, how many linear structures should I have in order to accommodate all kinds of students? Huh? All kinds of students. How many linear structures? Can I just use one? Okay. So now, think about it this way. Okay. So now I want to have is it possible to have a single linear structure that is going to hold both resident and non-resident students? I tell you what, the answer it should be yes, even though it's a very bad practice. It kind of corresponding to what you said the other day. Can I set the generics to be any? So now let me show you this. So now let me just go over this and then I'll mention another bad design. Okay? Let's say I want to have a class called Student Management System over here. That's a class. Now I want to hold both the resident students and non-resident students. I want to hold both kinds because they have nothing to do with each other. The only common ancestor they have is the any class. So what I could have said, of course, I can simply say students, and then I can simply say linked list of any. However, this design over here is pretty bad. That means not only that I can store students into my array, I can also store accounts. I can also store binary search tree. I can also store sorted map. Okay? True tolerance. Okay? So this is not good design. So now let's say we stick to simply I got resident students as a single structure. You're going to store resident students only and non-resident students, also non-resident students only. Now think about if you got 10 kinds of students, I need to have 10 different linked lists, which becomes very difficult to manage. Okay? What's more, let's say I want to have a particular feature over here called register all. I want to register a common course for all the students because we got separate linear structures. So now we have to go through them separately in order to register all the students, right? I got to go over all the students in resident students. I got to go over all the students in non-resident students and then simply register them for the course. It would be very nice if we can just have a single linear structure to store all kinds of students, rather than any, of course. And also, it would be very nice if we can just have a single loop to actually do the common operation for all the students. That's where the inheritance can come handy. Okay, but we'll get there. Okay, eventually, what we will get into is we'll have something called polymorphic collection. So this is something we'll get into once we talk about polymorphism. Okay, we'll get there. Okay, eventually. And polymorphic collection is requirements for all the design patterns we talk about after the reading week. So we'll make sure we finish that before the reading week. Okay? Guys, are we okay? Good. So now let's go a little bit further. Okay, we're almost getting to the case study. Let me just explain a little bit more. So now what we can do is we want to create some inheritance hierarchy here. We're going to factor out all the common code from resident students and non-resident students into a superclass called students. Okay, so here we got inheritance. Okay, you pretty much know inheritance well. So let me just go over the code. So student class, we basically put everything that's common to both kinds. We got name, we got courses, not premium rates, and not discount rate. And also we got a make feature here that's also common to both classes. And also we got register, which is completely duplicated between the two classes. We can factor that out into the student class. And now, for the case of the tuition, remember it's partially overlapped. So which means we only factor out the part about calculating the base amount. Okay? We simply say across the courses and simply calculate the base amount. And that's it. Okay? So that's the student class. So we're creating one more class in this case. So now the question is, how do we define the other two classes? Okay? That should be very relevant, similar to how you would do in Java. The only thing I want to show you is the precursor keyword. So we got resident students, and you say inherit students, and then redefine the tuition. Tuition is the only feature that we inherit, but also we try to redefine that. Okay? In the case of resident students, we're going to redefine that to be base times the premium rates. Okay? Okay, constructor here, and then premium rate, that's a new attributes we have, right? And also we got set premium rate, that's also a new feature. And also we got tuition here. And so now, one thing to show you very quickly. Okay, so now what you want to see is this neat keyword over here. Precursor. So what does precursor really mean? Precursor simply means, precursor, first of all, refer to this particular tuition feature. More precisely, it refers to the version of the tuition that is defined at the superclass level. Okay? So now the precursor over here, it refers to the version defined in the superclass. Okay? In this case, it simply refers to this particular tuition. So that means when I call precursor over here, it's as if I try to execute these 3 lines of code over here, simply to calculate the base amount. Okay? So once I do the precursor, I can say result is simply going to be the base multiplied by the premium rates. Okay? That's all I do. Are we okay with this? Just like how you use a super keyword in Java. Okay? The precursor. Okay, that's the only lesson I want you to learn from this particular example. Okay, similarly, you can see that in the case of non-resident students, you can definitely also call precursor over here. Okay? Oh, by the way, when you use a precursor, you can say precursor depending on which feature you're referring to. Precursor might take some arguments over here if you wish, if that's applicable. Okay? In this case, precursor is used as a query. So that's why we can say base is assigned to the precursor, because the precursor is simply referring to tuition that returns a real value. Yes?
Do we need that semicolon after precursor?
Yes, we need it. The reason is, even though in Eiffel code, it's recommended you simply put a new line as a semicolon. But if you're really constrained by the space, like in my case, you can put a semicolon. Yes. They also support semicolon, by the way. You can do that, even though it's not recommended. Okay, any question about precursor? Okay, we got about, well, only a few minutes. Let me just give you a little introduction over here about testing the postcondition violation. Okay, very quickly. Okay, so now what I will do is, okay, I'll try to go as much as I can. I only got a few minutes, but we'll definitely go into details on Wednesday. So now let's see how we can make use of the precursor keyword in order for you to calculate, to test the postcondition violation. Think about how you would do currently. You simply go to your implementation there, you kind of modify that to be something bad temporarily. And then make sure the postcondition it makes sure the corresponding postcondition is triggered to be violated. And then once it's triggered, you're convinced, you simply undo the changes for the bad implementation. That's how you would do. But you have a better way to do it using inheritance. That's why I want to show you a pattern. Okay? Let me talk about the pattern very quickly, and then we'll go into details on Wednesday. Give me a few minutes, okay? 2 minutes maybe. Let's say we have a class called account. Let's say that's a class we would like to test. And then we want to test specifically the feature called withdraw. Okay, withdraw, we have some precondition over here. And let's say we want to, let's say if the implementation is simply correct, which means we decrement the amount accordingly. And now what I want you to focus on would be this particular postcondition. Balance is equal to O balance minus amount. We want to test whether we can trigger the violation of this postcondition or not. Okay, that's what we want to test. So now we're going to use our inheritance trick over here. So what we do is we simply use the inheritance relation here. We create another class called bad account withdraw. Just a new class. And then I simply say I want to redefine this particular withdraw with the same signature as before. So now see what I'm trying to do here. I first of all call precursor. Okay, remember how the precursor can be used. Okay, let me just make it a little bit bigger. So now precursor is simply referring to the parent's version for the feature. In this case, I'm really referring to this withdraw over here for the precursor. Okay, I'm referring to that particular version, and then with this with the input amount over here. Okay, basically I'm just calling whatever version I define in the superclass, and then in addition to it, I simply do something additional. Okay, so this is the wrong implementation. Okay, are we okay so far? Basically, I'm creating a new class over here of the feature I want to test, and then I simply call precursor to make sure I do everything that's supposed to be done, and then I simply modify the implementation so that it's wrong. Okay, so now let's look at the critical thing here. Let's say now I want to test for the postcondition violation. I have a test account as a client, and then here I simply declare a variable of type bad account withdraw. So now when I say ACC.withdraw 50, so now the question is, when I call this particular withdraw, which version of the withdraw will be called, right? So now apparently we got two versions of the withdraw. This is version 1, and this is version 2. Which version am I calling? Version 2, right? You can see because the type is simply bad account withdraw. So I'll simply call this version here, which means it is going to execute the wrong implementation. Okay? And then there's something called subcontracting, which I'll mention a little bit later. And this particular contract over here is simply inherited to be the postcondition over here. It's inherited. So that means after this particular after this particular wrong implementation, we're still going to check this postcondition here, which will be violated. So that's how we test the postcondition violation. Okay? Let me just briefly touch upon this, and now we'll go with more details on Wednesday. Okay? I'll see you on Wednesday.